Let us start with experiment G for the pressure measurements. The main objective of this experiment is to do the calibration of the pressure transducer, which is fixed over here, This is the pressure transducer that's fixed on the dead weight tester. This is what we call it, the dead weight tester. Okay. The description and the components of this dead weight tester is available in the manual. Okay. You can see that you have two carriers for the weights, for the pressure calibrated weights. You have the lever in order to trap the oil, and you have the other valve in order to trap the oil. In this experiment, we have different plates that are pressure calibrated. So these are different weights. However, you can see that it's written over here as 10 kilonewton. So it is already calibrated as pressure, not only mass or weight. It is calibrated as pressure. It is 10 kilonewton per meter squared. So the small one is 10 kilonewton per meter squared. The larger one, you will see that it is 50 kilonewton per meter squared. And the largest one, you will find that it is 150 kilonewton per meter squared. So all of these weights are already calibrated, are already pressure calibrated. So now you are expecting when you apply any of these weights on one of these carriers, you are expecting when you apply these weights or these pressures, I can say these pressures, you are expecting to get the same pressure from the pressure transducer. Okay? But under two conditions, you have two conditions in order to be able to get the same pressure, or at least to make sure that you are doing the right experiment, to make sure that you are doing the right procedure in the experiment. Okay? If you want to apply pressure, you need to make sure that all the points inside the tank, all the oil points inside the tank have the same pressure. And to make sure from that, you need to be sure that there is no any point for the oil to escape when you apply this pressure. So if you apply any weight, you are expecting that the pressure that's coming from this weight will be reflected on this pressure transducer under a condition that the oil does not have any place to escape to. Okay? And in order to make sure that there is no any place or any point for this oil to escape to, you need to make two things. You need to trap the oil inside by doing two things. The first one is to rotate the lever, okay, inside, so you are closing the oil passes, and also open this valve. Once you open this valve, you are closing the pass inside the tank, so there will not be any relief for the oil. So in order to reflect the pressure from the plate to the pressure transducer, you need to trap the oil inside the tank. And to trap the oil inside the tank, you need to make two things. The first one, you need to open this valve in order to stop any relief for the oil. Okay? And the second one, to rotate this lever clockwise in order to close the passes and make sure that you have trapped all the oil inside. Okay? Actually, the pressure transducer, as it is explained in the manual, it is measuring the pressure using the strain gauge concept. So you are converting the change in the pressure to change in the deflection or change in the length of a diaphragm, which is reflected to change in the length of the strain gauge, which is reflected to a change in the resistance of the strain gauge. So you are converting the pressure to a change in the resistance, but you cannot measure this resistance using data acquisition card. Then you need to excite it. That's why you will find that we have a power supply. Okay? So the output from the pressure transducer is resistance, and we have a power supply. Once you adjust the voltage of the power supply, you are expecting to get a current corresponding to this voltage. Multiplying this current, or multiplying the output current from this power supply with the resistance, then resistance multiplied by the current coming out from the power supply, you will get the voltage corresponding to the resistance corresponding to the measured pressure. Okay? Then will be measuring the output from the pressure transducer as voltage corresponding to the measured pressure or corresponding to the applied pressure, We'll be measuring the voltage using two methods. The first one is the voltmeter, okay? And the second one is data acquisition card. This is the data acquisition card available over here, okay? You will find that it is similar to the data acquisition card of the vibration. However, you will find that the sensor of this data acquisition card is different. The sensor for the measuring the pressure is different from the accelerometer sensor of the vibration experiments. Okay? So what I'm going to do now, I'm going to measure the pressure, the voltage using the voltmeter, and also I'm going to measure the voltage using the data acquisition card. So I will have two sources for the measurements. One from the voltmeter and the other one from the data acquisition card at different applied weights or at different applied pressure calibrated weights. Okay, pressure calibrated weights. Then what we need to do now, I need to apply different weights on this plate. Okay, different pressure calibrated weights on this plate and measure its corresponding voltage, from the voltmeter and also from the data acquisition card using the lab view, using the setup on the lab view. Okay, I'll be measuring the voltage corresponding to the applied pressure at different applied pressure starting from 50 up to 550 kilopascal, which is the same as 50 kilonewton per meter squared, until 500 kilonewton per meter squared, step 50. So it will be 50, 100, 150, 200, 250, 300, 350, 400, 450, and 500. Okay? Keep in mind that each one of these, as we said, each one of these is 10 kilopascal or 10 kilonewton per meter squared. Each one from the medium size, it is 50 kilopascal, and the large size is 150 kilopascal. The large size is 150 kilopascal. Okay? And also, there are two plates. This plate, the smaller plate, weighs 10 kilopascal, and this one weighs 500 kilopascal. 500 kilopascal. I can use any one of them. I can use the smaller one or the larger one. As my pressure, my applied pressure ranges from 50 up to 500, so I'm going to use this one. I'm not going to use this one. I want to take care that this one weighs 10 kilopascal. So if I want to start by 50, I will add 4 pieces from this size till I got 50. Once I got 50, then if I want to switch to 100, I'll use just only one piece from this. If I want to switch to 150, I will add another one, so it will become 2. If I want to switch to 200, I will remove these 2 and add the larger one, and etc. Okay? So this is the method. So what I want to do, what I need to do now, for example, let us say that I'll apply the first one, I'll apply the first load, then what I need to do, I will open this valve to make sure that I have closed all the vent, all the relief for this oil. I will open it, okay, till the maximum, but I will not take it out, so it is okay now. Then I will turn this one until I can see that this table or this carrier just comes up. Let us see. Let us monitor what will happen. I will just run it slowly. I'll just turn it slowly. Let us see. Once it comes up, that's it. I'll stop. Let us see again. Okay, so now it means that I have trapped all the oil inside, and started to pressurize the oil, by these clockwise rotations, okay? So what is the benefit, or what is the target from using this screw and this valve? In order to trap the oil inside and make sure that the pressure from these weights is reflected to the pressure transducer. Okay? And now what I need to do, I need to go to the voltmeter and read the value, which will be 0.357 volt, 0.357 or 58 volt. Okay? And I want to read the same value from the data acquisition card, Now let us build a simple lab view code in order to read the data from data acquisition card of the pressure and also record the data of the voltmeter. So let us see how it will be. Right click, I'll go to Express, then Input, DAC Assist. Go to DAC Assist, Acquire Signals, Analog Inputs. Okay, I will select voltage. My sensor is connected to A3, then Finish. I have one added thing, okay, in this setup for the pressure transducer, that I need to go to device and select the coupling mode as DC, not AC, which is not available in the vibration measurements. Okay, and also in the settings, I need N samples. N samples, I should be acquiring only one sample on demand. However, it cannot be measured one sample on demand. So I will make it N samples, and I will just write this N sample as 2. Okay, N sample as 2, and I'm expecting that these 2 samples will be the same exactly. Okay, it will be just a repetition. So I will take only one of them. Okay, and I want to make sure that I got the same value from the voltmeter, the same as the voltmeter. So I will press run. You can see that it is 356.6 millivolt, which is 0.356, which is similar to the other one, coming from the voltmeter, similar to the one that's coming from the voltmeter. Okay, so you will find that both of them are close to each other, are very close to each other. So what I need to do now, I will go to the lab view. I will go back to the lab view. I'll press OK. Now my program is running well. So this is my data acquisition card. Okay. I will take the output, right click, and create numeric indicator. If I just press run one time, I'll find that it is 0.356. I'll find that this is 0.356. Let me try to make it larger for you so you can see what I'm saying. It is 0.356. It is 0.356. Okay, this is 0.356. So what I'm going to do now, I'll just add weights. I'll start the experiment again from scratch. I will add the weights. So now for the experiment, what I'm going to do, I'm going to add the weights, or add the pressure calibrated weights. Then trap the oil by the valve and the screw. Read the measurement from the voltmeter. Press run in the program, in the lab view program, okay, to read the data from the data acquisition card. And then go to the Excel file, and save all the data. For the weight, or the pressure calibrated weights, the voltage from the voltmeter and the voltage from the data acquisition card. And these data, I'll use it later on, or you will use it later on in conducting or solving the requirements in your report. Okay, so let us start the experiment again. Let us start from scratch and see how we'll do that. So as you can see, there is no any weights now. The valve, the small valve, is totally closed. The screw is totally released. Okay, and the reading of the voltmeter is almost 0. What I'm going to do now, I'm going to add 4 pieces in addition to the 10 kilopascal. Then I will have 40 plus 10, I'll have 50 kilopascal. And I'll do the measurements for the voltage. We're using the voltmeter, and the voltage using the data acquisition card. After adding the weights, as we discussed before, just what I need to do, I need to open this one. I need to open the valve. I need to open the valve. I need to close this one. Okay, and monitor the weights. Once it rise up, okay, then I should stop. I should stop turning the screw. So let us monitor. You can see that the pressure, the voltage is increasing. The voltage is increasing. Let us continue and see. It rise up. That's it. I don't need more. I don't need no more. You can see that we almost have the same value for the voltage. Okay? So it is 0.358. I'll go to the program. I'll go here and press run. Once I press run, I'll find that I got 0.355781, okay, which is close to the other one, which is 0.357, okay, and I will enter the values here in my Excel file, 0.357 for the reading of the voltmeter, 0.355781 for the voltage reading from the data acquisition card. What's next? I need to go to the next reading. So before that, I need to close the valve in order to let the oil escape. Let the oil escape. And please monitor the value for the voltage. In the voltmeter, you'll find that it will be decreasing step by step because the oil has escaped. Okay? And I'll open this one till the maximum. So it is totally released. This is totally closed. Now I want to switch to the next weight. I want to switch to the next weight, which will be 100. So I need to add another 50 to this 50. So I will add 150. So it is now 100. And I will again repeat it. Open the valve and close the screw or this wheel. Okay? So I will open it till the max. Okay? Then I will rotate this one, and I will monitor the change in the level of these weights. Once it comes up, then I need to stop. So I will monitor. I'll increase. I can see that the voltage is increasing in the voltmeter. So I'll increase. Okay, it comes up. That's it. Let me stop and let me go to record the value of the volt, which you can see as 0.719 from the voltmeter. And if I press run, if I go and press run from the program, I'll get 0.718793. 0.718793. Okay? Go back to the experiment, close the valve till the end. The pressure has decreased, oil has released, then, or relieved, then the wheel is totally open. What I need to do now, I need to measure at 150. So I will add another weight and do the same exactly. So now I'll do the same for 150 until 500. So this is the last weight, which is 500 kilopascal. You can see 4 by 10 plus 10, then 50, and 3 by 150, then 450. Then we have 500 kilopascal. You can see that the value of the voltage is around 3.62, something like this. Okay, and the value of the reading from the lab view, you will see that the value of the reading from the lab view is very close. So it is 3.63, very close from the other reading, which was around 3.62. Then, as we said from the beginning, the values coming from the data acquisition card and the other values coming from the voltmeter, they are very close to each other. However, you can say as one of the sources of the error, due to now that we have high pressure of oil inside this tank, you can see that with time the pressure inside the tank is relieving, and this one of the sources of error inside this experiment. Okay, because also we have some oil leakage from the tank which decrease the pressure with the time. Okay? So by this we are done with our experiment. Thank you.